Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this video we are going to discuss ARC-200 MOSFET based welding machine circuit diagram. I will explain the circuit diagram, its block diagram, control circuit and the different routine faults and their solution. To understand the function of this control card and the diagram of the machine, we will see the block diagram. Initially we apply 220 volt AC, it is single phase, and we take a 200 ampere maximum output current. Because it is current based power supply, we can say it is a power supply, because in arc welding machine just only we take care for the current. Make a welding, to make a spark we need a high amount of current. Apply 220 volt, there is an initial surge protector circuit. Why we need this surge protector circuit? Because these capacitors here are high value capacitor, about we can say 470 microfarad. So when these are empty, these are not charged, they make a very big surge. If the current is not limited, might be the capacitors will damage, or might be the bridge circuit will damage. The rectified voltage reaching to the capacitor, and then after a specific time when the voltage will start to build up, this power supply will turn on. The same 310 volt will apply to this SMPS circuit. It is low voltage power supply. It will turn on. When it will turn on, it will close this bypass relay. So this bypass relay will bypass this NTC or PTC, which is controlled to limit the current, surge current protection. So in that time we will take a bypassed voltage from this bypass relay. From this contact will closed. After that the positive line is connected to this MOSFET, negative line is connected to this MOSFET. Might be we have 5 or 6 MOSFETs in parallel, because it is half bridge topology. In half bridge topology we switch positive and negative voltage, and we use a resonant capacitor to discharge in the capacitor in the transformer. Then we have SG3525 based and CA314 operational amplifier based control card. In most of the welding machines this control board is used. It will switch. When it will switch, the pulse transformer will give the signal to these MOSFETs. These MOSFETs will apply these voltage to the transformer, and we will take rectified voltage in the output. As I said, this is current based power supply. To control the current we have a shunt resistance here. So this shunt resistance is used to measure the current. It is output current measurement, and here we have input current measurement. Why we need this? Because for switching we use 5 or 6 or more than 6 MOSFETs in parallel to switch a high amount of current. If we need 200 ampere in the output, we need a high amount of current. To measure the current, this current transformer is used here, CT. It is called CT. It will translate the flowing current in these MOSFETs. If the current will increase, it will detect and it will inform to the control circuit that there is a overcurrent. If there is a over temperature, because it is MOSFET and these MOSFETs dissipate power, at that time this temperature sensor will also sense the temperature, and it will also give information. If the temperature is high or the current is high, it will give OC or over temperature. In some machines we have overcurrent indication and over temperature indication. So let's check the detailed circuit, and then we will check the control card. Now we will see the detailed diagram. Here we applied line and neutral, and this is ground point. Line voltage are connected to the circuit breaker. When we turn on the switch, the voltage are applied to this NTC or PTC, to this surge protection resistor. Sorry, here is just only one bridge rectifier. One line is connected here, the neutral is connected here. I will correct it and I will upload this diagram in video description. You can take the link over from there. Okay, line voltage will pass through PTC and TC and it will reach to this bridge rectifier. It will rectify the voltage. These capacitor will start charging. This time the current is passing through this resistor network, that is PTC or NTC. Sometime it is 1, sometime it is 2. Now the capacitor, as we know, this is current, this is time. When we apply current, voltage, the capacitor draws too much current, that is inrush current. To protect this circuit from inrush current, to prevent from damage, the current is forced to move through this PTC and TC. So the current will move like this. When the current will start flowing and this capacitor will start charging up to a specific level, for example, we can say our this SMPS circuit, any IC here, it have a soft start circuit, it have a IC that can sense the voltage, the minimum voltage, we can say 90 volt. Above 90 volt, this IC will start switching. When the voltage will reach at 90 volt, at that time this IC, this SMPS circuit, this power transformer will start to give output. And now we will find 24 volt in the output. This 24 volt ground line is connected here and this ground voltage are connected to this relay winding negative side, and this fan negative side, this fan negative side. Positive 24 volt are passed to this relay. This relay will turn on. When this relay will active, it will make this contact so that the voltage and the current which were forced to move through this NTC or PTC resistors, now it will move through these contacts, because now it will provide a easiest path, so current will flow from here and the capacitor will charge at full rate, and our next circuit will become capable to drive the other power circuits. Same positive voltage are applied to these fan circuit fans, so these fans will turn on and it will start cooling to the heatsink of the machine. Positive voltage are applied to this current transformer. So current transformer is a device which monitors the amount of current. For example, in primary, if we can say here is 10 ampere, in secondary it will induce 1 volt. 20, it is an example, 20 ampere 2 volt, 50 ampere 5 volt. So it is a ratio based transformer. How much current is flowing in the primary, in the secondary, the sense voltage will increase linearly. Positive voltage will reach here. Here we have 1, 2, 3, 4, 5 MOSFETs in parallel, positive side and ground side. We are applying positive voltage and it will complete its cycle from this capacitor. When this pulse will turn off, because these are opposite to each other, it is high, at that time it will low. When it will low, the second will high. Both MOSFET sets are working opposite to each other. When this will turn on, now it will connect the ground side to the winding and it will discharge in this capacitor. Because this is ground, this is positive, this is more positive, because the capacitors in series make a voltage divider network similar to a resistor. To increase the amount of current, 5, 6 MOSFETs, 4 MOSFETs are used in parallel. Now here the signal value will transfer to X8 connector or some number of pin, because different machines from the same manufacturer for the same models are using different techniques. Here maybe it is a connector based circuit card, control card. In the other maybe you will find the soldering circuit card, and maybe in the third power supply that will the built-in on the main power board. So it is different techniques to make a circuit card, which is the cheaper one. They produce it. 24 volt are applied to X6 connector to the control card. X7 connector will drive this pulse transformer. X4 connector is connection for the temperature sensor. X2 connector for the front panel potentiometer to set the current. X1 is connected to connect the display, and X9 is for overcurrent LED. X3 connector is used to sense the output current. So in output side, in the negative line of the electrode, we have a resistor that is called shunt resistance. So it will give a signal how much current is flowing from this shunt resistance. Most of the time it is in ampere to volt. For example, at 100 ampere it will provide 0.8 volt. Some shunt resistors will provide at 100 ampere 80 millivolt. It depends on the type of the shunt resistance. When these MOSFETs will switch time to time, there will a bidirectional current flow in the primary. In the secondary, we will find output voltage. Then we have a rectifier set for output section. It will give positive output here. It is showing two sets. So two sets are providing here positive voltage. And the common of the winding is giving ground line in the output. Let's check the control card. In control card, as we discussed, we apply 24 volt here. Positive, negative. This is from LVPS, low voltage power supply. That is 24 volts. So 24 volt are applied to this capacitor. This capacitor is charged 100 microfarad capacitor. Then these positive voltage are reached here, and it will enter in this LM7812 regulator. The output of this regulator is here, and we will take this regulated 12 volt here at pin number 15 of this SG3525, and it will also reach to the pin number 7 of this CA3140. So this IC will energize, it will take power. Pin number 12 of SG3525 is ground. It is connected to ground line. Ground is coming here. This lower line, bottom line, that is ground line. Pin number 1, that is connected to ground. And when we apply positive voltage and ground, this IC provides 5.1 volt or 5 volt reference voltage. So 5 volt will come out from pin number 16, and it is connected to pin number 2. Pin number 1 is connected to ground, pin 2 is connected to 5 volt. This is inverting and non-inverting inputs of the error amplifier. When inverting is connected to ground and non-inverting connected to positive, so this IC have to utilize the maximum duty cycle. So it is programmed, the error amplifier is programmed to take a full control to switch. Pin 3 and 4, sync and oscillator output, left blank, not connected. Pin 5 is CT, 1 nanofarad capacitor. In different machines the value may be different based on the switching frequency. And RT, timing resistor. RT and CT, two components are used to determine the frequency. How much frequency will be in the output stage. Then we have pin number 7, that is discharge control or dead time control. So it is connected to pin number 5. That means it is zero resistance. Then we have soft start. This soft start is used to start this IC slowly, linearly. Then pin number 9, that is compensation pin. It is the most important pin of this IC. We will discuss with this circuit. Pin number 10. Pin number 10 is shutdown pin. Shutdown pin is connected directly to the ground. If it is connected to ground, this IC will turn on and it will work regularly. If we apply positive voltage to this pin, this IC will shut down. In some circuit cards, in some control cards, the positive voltage are switched from any transistor in case of overcurrent. In that case, if we find 5 volt here, this IC will turn off immediately. So it is shutdown pin. Pin 11, that is output pin for channel 1. Pin 12 ground, pin 13 is VC, collector voltage, for the output switch. Here we have to apply VC voltage and pin 12 is ground, so we will take output from pin number 11 and pin number 14. So here we have gate drive component for this full bridge switcher. This full bridge switcher, it is using 4 MOSFETs. 1, 2, 3 and 4. Sometime it is using separate MOSFET, sometime it is using 8-pin IC. Different control cards maybe have different. Might be the same model, it is using different type of control cards. So we can say 98%, 99% function will remain same. Might be the physical layout and the circuit layout may be different, but the circuit working phenomena will remain same. This IC started switching. It will switch channel A, channel B, opposite to each other. It is using two switching transistors, NPN and PNP, to control the gates of these MOSFETs. These will work in cross. So this P channel and N channel MOSFETs will work opposite to each other to drive this transformer. Here we are using NPN, PNP, and here is P channel and N channel MOSFETs, which are working opposite to each other to drive this pulse transformer. This pulse transformer is shown here from X7 connector. So it will start pulses opposite to each other to drive these MOSFET network. Here we have soft start control circuit. This is temperature sense circuit, and it is OC switching circuit, overcurrent switching circuit. First we will see this circuit. We said we applied 24 volt from this line to here to this 7805 IC, and we are taking 5 volts. In some control cards, 7805 and 7812 are on the main power board. Here it is using on the control card. If it is on the control card or on the main board, the story will remain same. We need 12 volt for this IC, 5 volt for this circuit. This 5 volt reached one end of the potentiometer, reached one pin of this display meter, the ground line, which we said it is reaching here. So this ground line is reaching here to pin number 2. Ground line here, this pin, it is reaching here. We applied positive 5 volt and ground, so this display meter will active, it will energize, it will ready to take some measurement. Positive voltage applied to potentiometer one side, and if we say the second end, the last end of the potentiometer, that is connected through this 100 ohm resistor to the same ground line. This is ground line, which is 24 volt ground, low voltage power supply ground. Now we applied positive, we applied ground, and we take some output from this potentiometer depending on the amount of the resistance which we are tapping from here or from here. This is positive 5 volt, this is ground. How much resistance we tap? If it is closer to ground, less voltage will come in the output, and these voltage are applied to 5.1k resistor and this 5k potentiometer, and then it is connected to measurement pin of this display meter. It will display the amount of voltage which we are tapping. Actually we are setting the amount of current, but in the background we are tapping the voltage, and this tapped voltage are sent to this multimeter to display. If we will set 0, multimeter will show 0. If we set to mid-range, it will show 100. That means these voltage are reaching from here. So we have to calibrate. If sometime if we set to 0 and it's showing some amount of voltage, some amount of ampere, for example it is showing 10 ampere, 20 ampere at 0 of the potentiometer, you have to adjust this potentiometer. Some machines, when we rotate full knob to the end, it display, for example machine is for 200 ampere and it will display just only 150 ampere, 160 ampere. So we have to increase or decrease this resistance to take a full rated measurement, a full rotation of the potentiometer. So this is adjustment for calibration. We apply some voltage to this potentiometer, that's a 20k 600 ohm resistor to this point. We said CA3140. In some boards there are some other type of operational amplifiers, but the phenomena is same. It have to amplify the difference between the two pins. Pin 3 is connected to ground, that is non-inverting input. Inverting input, that is connected here. It is inverting amplifier. So this voltage, we set some amount of current. So this amount of voltage will reach to this pin. So this IC will give output and it have a feedback resistance. It will control the compensation pin to increase the duty cycle. So this IC will start to adjust duty cycle in the output. To adjust the turn on time vs turn off time of this pulses. The voltage are maintained in the output terminal here. All circuit is switching, output maintained here. When we connect a rod to any job, it starts arcing, it starts welding. At that time current flows in the transformer in the output side, and how much current is flowing through this shunt resistance, it will tape voltage and it will send to X3 connector. We take two wires from this shunt resistance and these wires are reaching here, X3 connector. How much current we need and how much current is flowing. For example, we set 100 ampere. At that time we are applying 1 volt. It is example. Our job is drawing 60 ampere and it is giving, we can say 0.6 volt for example. So we need more current. So this IC will say there is a difference between the requirement and between the output. How much current we need and how much current is flowing, it will adjust and it will amplify the difference on this node, on this pin, inverting amplifier pin, and it will adjust the biasing of this transistor and it will control the conduction and it will give a compensation voltage to pin number 9. For example, we set 200 ampere and the job tries to draw more than 100 ampere. Anytime the voltage will increase, it will increase its conduction so that the IC will decrease switching and it will limit the switching at our requirement. So this is the procedure. This is the working phenomena of this IC. As I was discussing here, for the current sense current transformer circuit at this resistor network, this configuration, here we have MCR 100, that is SCR. SCR have terminal 1, terminal 2 and grid trigger. We apply some feedback signal, some sense voltage that are reaching here. For example, this circuit is allowed to work with 3 volt. We can say we are, as per this ratio, for this example, 30 ampere 3 volt. If the current will increase in this section, it will increase the amount of voltage. For example, we receive 4 volt pulses. That means the current exceeded from the allowed limit. Allowed limit is 30 ampere and we are taking 4 volt. That means the overcurrent is in the circuit, so it will cause to trigger this SCR. So this SCR will trigger and it will conduct this ground line to this point, this LED. We applied through current limit resistor 5.1K and 24 volt are applied to this LED here and this LED here. That is in the front panel, this is on the card. So this LED will turn on. Now what will happen? This ground level will also pass to this transistor, and this transistor will switch and these will turn off this IC, because pin number 8, that is soft start. So this IC will turn off. Why? Because there is a overcurrent in the primary section. The second thing, if our fan is choked, the duct is closed for the heatsink, or due to any reason the MOSFETs are dissipating the heat, maybe we replaced some MOSFET for other type which have RDS more than the suggested value, it will dissipate more power. When it will dissipate more power, the temperature sensor might be at 90 degree, 96 degree, 98 degree, what is its category, it will switch. When it will switch, it will give a signal to this transistor, and same time it will pass signal here. This transistor will switch, this ground voltage will switch, and this path will turn on, this LED will on, OC light will on, and this transistor will triggered so that the IC will turn off. In some circuits, this transistor is connected to over temperature and this SCR is connected to over current. So we will take two separate circuits for over temperature and over current. But in this circuit, it is showing just only one LED. This machine have one LED, that is OC, overcurrent. Overcurrent, that means we have two problems. Might be we have overcurrent, might be we have over temperature. So friends, I hope so this video is informative. If it is informative, hit the like button. If you have any question, kindly let me know in the comment box. I will give the link of these diagrams in the video description. You can download it. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.